Good morning, everybody. How's my period 4 class doing? I hope you had a great spring break. It was kind of nice to relax, right? But we're back now. And I hope you read the email from Dr. Greenwood. We're going to change up the schedule a little bit, starting on Thursday and Friday, going to blocks type schedule. But I'm sure you'll be getting, if not already, another email about it to let you know how it's all going to work. Okay? But for today, Monday, April 20th, and tomorrow, we're just going to be doing the same type of thing we've been doing. All right? So I still am going to probably aim for once or twice a week doing a live video Zoom when it's appropriate. Right now, we are going to just kind of review. I'm going to give you kind of like an overview of what we're going to be doing this next week. You are going to be having a quiz probably on Thursday. Okay, let's aim for Thursday, a quiz on 9.1 in your textbook, okay? So that deals with the elemental forms of carbon, and if you go back to our video lessons from way back, we talk about elemental carbon. Do you guys remember the 3 forms of elemental carbon that we talked about? Those are the substances that are made up of only carbon atoms, carbon bonded to carbon. Do you remember those? Why don't you think for a second? Remember diamond, graphite, and fullerene, okay? So we are going to have a quiz that has that information, plus about the straight chain hydrocarbons, alkanes, alkenes, alkynes, and all of that. You can go back to all the video lessons from that prior to us breaking for spring break. Go back to the notes that you took. Remember, so important to take notes on all my video lessons. So important. So make sure that you go back to those if you need a refresher. Okay, and we ended before break, we talked about isomers, and some of you still haven't finished that isomer homework. Please make sure you do, because grades have to be in for 3rd quarter by Thursday. And if I don't have a grade for that isomer homework, it goes in as a 0, okay? And I don't want that to affect your grade. So please be careful. Please make sure that every day you go to your assignments and make sure you do all the assignments that you have to do, okay? All right, if not, then I wind up emailing you and your parents, all right? You don't want that. So make sure you follow up with your assignments, and any questions you do have, please let me know. All right, so we started talking about, I'm going to go back to this video share. We left talking about isomers, okay? Let's go back about isomers. Where did we see that? Remember, what is an isomer? There it is. What is an isomer? Let's go over that, because that was really the last thing we talked about, and you did that isomer review sheet. Remember, it is a hydrocarbon that has the same molecular or chemical formula, but different structural formula. And here was an example. And isomers only happen with alkanes, okay? That's single bonded. So here's an example, butane. And for your quiz, you do have to know the prefixes, okay? So here we have butane. That's butane. But is 4 carbons. A and E is single bonded. Everything between the carbons is single bonded. And then we fill in the hydrogens. And when we do so, it's C4H10 is our structural or molecular formula. An isomer, remember the definition is the same molecular formula, so same molecular or chemical formula we call it, but the structure is different. And remember what is different about the structure for isomers? They're branched, okay? They're branched, all right? Here we only branch in the middle. Remember, we never branch on the end. And it does have the same chemical or molecular formula. And if we count the number of hydrogens, it's still 4 carbons and 10 hydrogens, okay? So now we're going to talk about, we talked about alkanes, we talked about alkenes, and I'm going through, we talked about alkynes, they're the triple bond, right? We talked about isomers. So now we're going to talk about a type of hydrocarbon that is called a ring hydrocarbon. Now, please remember, this would be just like me standing up in front of the classroom, talking to you in front of the smartboard. Please take notes, okay, in your binder, just like you would. All right, so ring hydrocarbons. So what do you think about ring hydrocarbons? How do you think the carbons are arranged? If you said ring, you are right. They are arranged in a ring, okay? So they arrange in the ring, okay? And 2 ends of the carbon chain are just attached, right, into a ring. They call them cyclic. Cyclic means circular, okay, ring hydrocarbons. And you know by their prefix that they're arranged in a ring. They start out with cyclo. Okay, so let's look at this. Let's look at cyclohexane. So a lot of clues in this. Cyclo prefix is telling us that these carbons are going to be arranged in a ring. Hex tells us how many carbons. How many carbons for hex? Why don't you think about it? If you said 6, you're right. A and E, remember, is telling us whether the ending is telling us whether it's an alkane, alkene, or an alkyne. It ends in A and E, so it's an alkane. So that means we're only going to have single bonds. All right, so it's 6 carbon atoms arranged in a ring, all single bonded, right? Very simple. Let's draw the structural formula. There you go. The 6 carbon atoms arranged in a ring. There's your single bonds. Now we're going to fill in, just as we do with everything else. This carbon has 2 bonds. It needs 2 more to have the 4. And then you fill in. This carbon has 2, needs 2. This carbon has 2, needs 2. So it comes out with the formula of C6H12. Okay? C6H12. All right? So there are a few ring hydrocarbons that are called aromatic hydrocarbons. What does aromatic means? It means a smell. And that's exactly what these are. These aromatic hydrocarbons are a special group. They're unsaturated, remember, because they're unsaturated for this reason. They have single rings or groups of rings, but they're unsaturated because there is a double bond somewhere. All right. The most common aromatic hydrocarbon is benzene. Now it's called benzene. It's kind of like how, let me try to think of an example for you. Sometimes we think of common names. So benzene is actually cyclohexene. Okay, hex. All right. Cyclo because the carbons are in a ring. All right, but what's different is it is an alkene. How do we know? It has double bonds. And what's peculiar about this is there is a double bond at every other carbon bond. So here we have a carbon to carbon double bond, and the next one is a single bond. Next one is a double bond, the next one is a single bond. This is the only aromatic hydrocarbon that you have to be responsible for, that you are responsible for, okay, is benzene. Technically, it's called cyclohexene, but we don't call it cyclohexene, we call it benzene, okay? So let's look, how do you draw this? Here's this carbon. How many bonds does it have? 1, 2, 3, so that means it needs one more. You just put in one hydrogen. This carbon, how many bonds? 1, 2, 3. You need one more hydrogen. And of course, for all of them. So when it's all said and done, you have 6 carbons. How many hydrogens? 1, 2, 3, 4, 5, 6. H6. Okay? So aromatic hydrocarbons, the only one that you're responsible for is benzene. Okay? No, what's different about benzene is that it is actually an alkene, and every other carbon atom is bonded to a double bond, and we call it benzene, okay? And that molecular chemical formula is C6H6, all right? So let's kind of practice on this. I'm going to, let's practice some more. Hold on, I'm going to move myself on our Jamboard here. Okay. Let's practice a new Jamboard. Okay. Let's practice some cyclo or cyclic. Okay. How about pentane, sorry. Cyclopentane. Do this with me in your binder. We have a lot of clues here. Cyclo, telling us that our carbons are going to be in a ring. Pent tells us how many carbons. How many carbons? Think about it. Pent. If you said 5, you're right. And A&E is telling us that it's all single bonded. All right, so let's put our carbons in a ring. That's 3, 4, 5. Right? 1, 2, 3, 4, 5. Okay? And you know what? Let me do this a little bit better here. I don't like the way that is. Okay? So we have pent is 5 carbons, A&E, they're all single bonds, cyclo in a ring. So now we're going to add our hydrogens, right? This carbon right here, how many bonds does it have? 2. We need 2 more hydrogens. This carbon right over here, how many bonds? 1, 2, needs 2 more. This carbon right here, how many bonds? 1, 2, needs 2 more. Right? This carbon right here, how many bonds? Has 2, needs 2. Remember, every carbon needs 4 additional bonds. Has 4 valence electrons, needs 4 more bonds. All right, so what's the chemical or molecular formula? Well, we know C5, H, 1, 2, 3, 4, 5, 6, 7, 8. Oh, we forgot this. We forgot this one. There we go. So C5H10. Okay? That's it. All right. So for today's homework, tonight, you're going to get a a sheet that is a total review of all the hydrocarbons we talked about: alkanes, alkenes, alkynes, isomers, and now the ring hydrocarbons, okay? That's what you're going to have on your quiz on Thursday. So please don't let me chase after you. Your homework that is due tomorrow before class begins is to work on this practice worksheet. This is going to help you review for your quiz. It is due, and it is a graded homework assignment. If I do not have it by the start of class, I am sending an email to you and CCing your parents. So please make sure you get these homework assignments in. It's very important. Okay? All right. So that's it. If you have any questions, be sure to chat with me during our class time. I'll help you out, whatever I need, whatever you need. Have a great day. Do your homework, and I'll talk to you tomorrow. Bye.